Okay, we graph this function, x squared minus 2x plus 5. Wait a minute. Is it minus 5? Okay, that looks better. So, looks like it comes all the way down. I have a degree in graphing by hand. You wonder why they gave it to me. So, domain. Are there any x values that do not have representation on the graph? No, they're all there. So my domain, x equals the real number set. Are there any y values for my range that do not have representation? Stuff below negative, looks like 6 to me. Below negative 6. So my range would be negative 6 comma infinity. Negative 5 is the y-intercept, but the graph actually goes 1 below negative 5. So the y-intercept is right here at negative 5, but the graph actually goes down to negative 6. Does that make sense? So, is negative 6 included in the range? Yes. Is infinity? No. So for the y-intercept, you just look at the constant of the graph, or you can always plug in 0. So, oh, how nice was that? So second calc value, and I plug in 0, and I get negative 5. And you can see that the graph actually goes down 1 more from there. I did second calc, and then I want to find a value. And I can find any y value I want if I plug in an x. The x I'm looking for is x equals 0, so that tells me that the y-intercept is negative 5. Yeah. Apparently you weren't paying attention yesterday. That's okay. All right. These x values don't look like very nice numbers, so we need to do second calc, and then we're going to find the zeros. And I tend to call them roots most often. So if you hear me say roots, I mean zeros or x-intercepts. Eventually, we're going to stop using the words x-intercept altogether. We're going to use the word root or 0. So on this left side, it looks like negative 1.5. So I'm going to put left bound negative 3, right bound 0, and my guess I'll see negative 1. And one of them is negative 1.449. I can do the same thing for the other side. Find the 0, somewhere between 2 and 5. And I'm going to guess 3. And my answer is 3.449. So those are the two x-intercepts. Okay. If you don't have that worksheet, grab one. So let's graph the first equation, which is the same equation that was on yesterday's worksheet. In fact, most of the functions that were on yesterday's worksheet are on today's worksheet. I had to change some of them because they didn't do what I wanted them to do. So 4x minus 32. I'm going to graph this. And today, instead of looking for domain and range, or x-intercepts and y-intercepts, we're going to find the intervals of x that yield positive numbers. So it's asking, which x's can you plug in to get out negative y's? Or which x's make the function negative? Well, visually, what does it mean to be negative on a graph? Below the x-axis. So which x's can I plug in and get a value that is below the x-axis? 7 would give me a negative number. Is there a bigger number that would give me a negative number? would 8 give me a negative number? What does 8 give me? So if I went second calc value and I plugged in 8, I get 0. Well, what if I plug in 7.9? I get a negative number. So, so what is the interval of x that creates negative numbers? Negative infinity up to 8. Does 8 create a negative number? No. So I'm going to say my positive intervals of x are from negative infinity up to 8. Do we include 8? Nope. Oh, sorry. That's negative. Some of you have perturbed looks on your faces. Okay. Does that look better? Okay. What would be my positive intervals of x? 8 up to infinity. Does everybody get that? Well, good. That's a good question. Is 8 included in my positive interval? When I plug in 8, I get 0. Is 0 positive or negative? Neither. So at 8, we have no positive or negative numbers. We have 0, which is neither. All right? So let's graph the next one. Make sure you draw the graphs on your paper. Negative 6x plus 8. What intervals create positive numbers? We have a problem. What number gives me a 0? Some number between 1 and 2. And yesterday when we had this function, we played the guessing game, and we decided we didn't like that. So let's do second calc and find the root, or the 0. Second calc, 0. And my bounds will be 0 and 2, and my guess will be 1. And my 0 is 1.33 repeating. So what would my positive interval of x be? What's the lowest number that gives me a positive value? Negative infinity. Right, looking at the graph is positive on this side. So everything left of 1.33, so from negative infinity up to 1.3 repeating, and we never include negative infinity. Do we include 1.3? No, because that is 0, and 0 is not positive. Can you think of an instance when it would be a closed circle? Right, the function would have to stop before it got to the x-axis. So if we had something like this, and it was filled in, then that entire portion is negative, and there would be no open circle. All right, how about my negative interval of x's? 1.3 repeating all the way up to infinity. And that would be the bottom portion of that graph. And 1.3 repeating is neither positive nor negative because it's 0. All right? So my next graph, x squared minus 4x plus 5. What intervals of x yield positive numbers? All of them. What intervals of x yield negative numbers? None of them. So you can say that this graph is positive everywhere, and it's negative nowhere, or it's never negative. Another way that you might see this is the positive intervals of x would be negative infinity to infinity, which is the interval of the entire real number line. And if it's negative, you might see something like x equals the empty set, that funny zero with the line through it. That means, in set notation, x is positive for every number inside the set that has nothing in it. So that symbol means empty set, and we use that all the time in higher mathematics, which is really weird. We create a set, and there's no number inside that set. Okay. Number 4. Number 4 is going to trick you on purpose. Negative x squared minus 10x minus 25. Oops. Not minus 2, minus 25. Where is this graph positive? Nowhere. Where is this graph negative? Good. Everywhere except negative 5. When x equals negative 5, the graph equals 0. So there are two ways to write the negative version. The positive is just nowhere. For my negative intervals of x, I could have the real number set except x does not equal negative 5. Which means everywhere except negative 5. The other way to do that is negative infinity comma negative 5, and then negative 5 comma infinity. Those two intervals make up the entire real number line except the number 5. All right? Graph number 5. So x squared minus 4x minus 18. Do those roots look like integers? Do they look like whole numbers? Not really, so we better test them to see. So we'll find the left root and the right root. The left 0, it looks like it's negative 3, so I'll plug in negative 5, negative 2, and negative 3. So what would be the positive version on the left side? So my positive intervals of x would be negative infinity up to negative 2.69. And the other one, it looks like it's about, what is that, 7? So I'll say 6, 8, and my guess will be 7, 6.69. So what's my second interval of x? My positive interval of x. 6.69, comma, infinity. So I'm positive over here on the left and over here on the right, and everywhere in the middle I'm going to be negative. So my negative interval of x is x equals, what's the low end on my negative side? Negative 2.69, comma, 6.69, and I'm done. Anybody need help with that? Need more explanation? Okay. My next graph, negative 8 divided by x. When is this graph positive? But, but isn't that true of every graph? Every time it's above the x-axis, it's positive? What values of x give me positive y's? So from negative infinity to 0. Everything in quadrant 3, or quadrant 2. So it's positive when x equals every value from negative infinity to 0. Do I include 0? It never actually gets there. Now this is different from the other problems. We never included a value that made the graph 0, but here is an x value that doesn't even exist. There is no x equals 0, because when you plug in 0 into that function, you get infinity. So that is open. And when is the graph negative? From 0 up to infinity. All right, I'm going to give you a couple minutes to work on the last 3 on your own. On number 8, we end up with a function that looks like this. It goes up through negative 2, and then it turns around and hits negative 1, and it turns around again and hits 2. Now, don't get confused between going up and going down, and above the x-axis and below the x-axis. All we're doing today is above the x-axis or below the x-axis. So I have this little portion here that's above the x-axis. What is the interval for that positive region? From negative 2 to negative 1. It hits the x-axis at negative 2, it hits it again at negative 1, and everything in the middle is above the x-axis. So my positive intervals of x, negative 2 to negative 1. The other positive portion is over here. What is the x interval associated with that positive version? To infinity. I knew you'd say it. Okay? So when is this graph negative? Well, we have 2 negative regions. Here is a negative region, and here is a negative region. So this region on the left, what is the smallest x value that belongs to that region? Negative infinity. And then it stops at negative 2. Okay? This little section in the middle, what is the interval for that? From negative 1 to negative 2. Oh, thank you, positive 2. Okay? And then number 9 is a little bit tricky. Does it look like this? Well, almost. So it's like this, and then like this. Okay. There is a vertical line here which has no graph on it. And that line is at negative 4. Now, if your graph draws that line, did anybody's graph draw that line? Somebody have it plugged in? Remember, if your calculator, if your calculator draws that vertical line, remember it's not actually there. It looks like there's a vertical line, but there is no graph at that point. Your calculator is just trying to be smarter than it is and trying to connect the dots. So it's not that smart. So when is this graph negative? So if we look at this portion down here, it's negative when x is negative infinity all the way up until negative 4. So negative 4. And it's also negative. Oh, I moved my paper. this should be right there. When does it turn negative again? At 0. So over here, from 0 on, it drops below the x-axis. So 0, comma, infinity. What would my positive region be? From negative 4 until 0. All right. I guess on the second page, the instruction tell you find the intercepts. Ignore that. Your job is to find the positive and negative intervals. There are two functions at the bottom of the page that you don't know how to graph, so I graph them for you. They're a little bit tricky, but just look at the graph to find the answer.